This video demonstrates how to model the United States economy in MATLAB using a vector error correction or VEC model. Starting with historical macroeconomic data, we will estimate the VEC model and then use it to generate forecasts and analyze economic shocks. We begin with 7 indicators, including GDP, wages, hours worked, and the federal funds rate. This raw data tends to trend upward over time. Because these series are on different scales, their raw levels can be misleading. Using logs helps us focus less on absolute size and more on growth rates. We start by opening the Econometric Modeler App and importing our dataset. Now, we move into model estimation. A VEC model is a good fit here because these macroeconomic series are non-stationary, but they can still share stable long-run relationships through cointegration. The workflow starts with the Johansen test, which we use to choose the cointegration rank. In this example, the VEC lag length is set to 1, meaning the model uses the previous quarter's changes to help explain the current quarter. Because the series shows clear trends, we test 2 Johansen terms that allow linear trends, H* and H1. For more information on how to choose the appropriate deterministic term, see the JCI test documentation. For H*, the test statistic first falls below the critical value at rank 3, suggesting an estimated rank between 3 and 4, although the result is somewhat marginal. For H1, the result is much clearer, and the test more strongly supports a rank of 4. To decide between the two, we run a likelihood ratio test. The test fails to reject H1, indicating that the additional trend term in H* does not materially improve the fit. Based on that result, H1 is selected. With that structure in place, we estimate the VEC model. We select H1, set the cointegration rank to 4, choose 1 lag, and then click Estimate. The app shows the estimated model coefficients in the parameters table. The cointegrating relation plot shows the long-run relationships among the variables in the system. Those lines remain relatively stable over time, although they become more volatile around recessions. Next, we click Forecast to generate a forecast for GDP. Once the analysis is complete, we can click Export to generate either a live function or a report. This makes it easy to capture the workflow, reproduce the analysis, and share the results outside the app. Now that the model is fitted, we can ask a more concrete question. What happens when the economy experiences a shock? That's where impulse response analysis comes in. We apply a 1 standard deviation shock to 1 variable at a time and track how GDP responds over the next 10 years. In this example, the responses show that shocks can leave a lasting effect on GDP. If you want to explore more advanced workflows, this example also covers rolling out of sample forecast evaluation for real GDP, forecasting around the 2008 financial crisis with uncertainty bands, comparing the Great Inflation and Great Moderation periods, and conditional forecasting and simulation using CBO projections. Visit the documentation page to explore the full workflow, code, and additional resources.